Okay, we have seen like string, unstring, and inspect. We have seen, right? So today we'll be seeing about signed values, decimal values. Okay, and then we will see um, comp variables, etc. Okay, variable sign. So what I'm trying to teach today is usually we are having values for a numeric value. Let's say uh, I'm having a number that is 01 WS number one. Pick, let's say I'm having number 9 of 05. So usually what we are doing, we are giving some value which is having no sign. It is not having any plus sign or it is not having any minus sign, right? So it is not having any plus sign or it is, if suppose if we want to deal with the signs, right? So how we will be able to declare that? That is the like point now, how we are going to deal it. So when you're having 9 of 5 or 9 of 4 or 9 of 3, something like that, you will have to, if you want to deal with sign, you have to add an extra letter called S. S 9 of 5. That means signed number. So as of now, we have seen simply 9 of 5, 9 of 10, 9 of 15, like that. So we're going to add S. S 9 of S means it is talking about the sign of that number. Okay. Let's say I'm having another number called. So if sign is there, how it will store? That's what the question is. If let us say we are having sign, so how we will be able to store the sign? Like whether it will be storing in the plus, if suppose plus 1 2 3 4 is there number, so it will show as plus 1 2 3 4 or 1 2 3 4 plus or any other way how it is following. So we will see. So let's say for this I will be giving the value uh, let's some 9 of 4. Let me give plus 1 2 3 4, sorry, plus 1 2 3 0. Okay, let's say this is the value for this. And for this, plus 1 2 3, sorry, it is minus 1 2 3 0. Okay, these are the values we have. So for the first one, I'm having the value plus 1 2 3. And for the second one, I'm having the value minus 1 2 3. So for now, first what I'm doing is I'm just displaying display WS num1. Here I'm displaying WS num1. And similarly, I'll save it. In interviews, they will ask you one question. They will give you one append code like 4098 or 40 something, and they will ask you what is the reason for that. Okay, I'll show you why it will come. So this is fine. And when you are running, you will get an error. So it is saying, what is the user event code 4038? In interview, mostly they will ask you, what is the reason for U4038? Okay. So you observing any mistake or any problem in our code?
Nine of 04.
So 04 and everything, 4, if you're giving 4 or 04 is fine. Here the thing is, we didn't run the stop, we didn't write stop run. So did you observe that? So we did not write stop run. So if you're not writing stop run in your program, you will get U4038. That means what will happen is your program will be completely in waiting stage, meaning it will be waiting like, okay, stop run will come, stop run. So it will be keep on waiting for stop run, but stop run is not there. So that's the reason you will get U4038. Got it? So in interview, if they are asking, you can say this. If we are, uh, if we miss to write stop run, then we will get U4038. Okay. So now we have to compile again. Maybe from the spool we do easily. Start ST, then SJ in front of compile job, submit. So this is fine. This is also fine. So now let us see. So it is storing in a different way. Okay. So 123 is fine. When it is plus 1230, it is storing in this way. When it is minus 123, it is storing in this way. So usually what will happen here is it will be storing the data in zone decimal format basically. So I'll tell you, just by zero, you will not be understanding. So here at least we understood one thing, that sign will be stored in the last half byte, or along with the last number it will be stored. Okay, so so it is simply zero, right? So we are not understanding. So what I will do is plus 1230 as, so what I'll do is display. I'm saying plus 1230 stored as, so how number. So plus 1 to my value is plus 1230, but it is stored as, it will display whatever the way it is stored inside this. Okay. Now what I'm doing is add plus 1 or simply 1, anything is fine, to WS num1. So what will happen? Tell me what will be the value of WS num1 now? I'm adding just 1 to that.
1231.
1231. So display plus 1231 stored as WS num1. Again, I am adding. So up to 9 we will add. That means what will happen if the last is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Up to 9 way. So I'm adding again 1. So what it will become?
Plus 122 stored as.
Stored as, sorry, add plus 1 to WS num1. So what we do, we will maintain one gap so that it will be easy. Plus 1, this is 1, 2, 3, 1. This is 1, 2, 3, 2. Okay. Now repeat this set RR. This will become 1, 2, 3, 3. This will become 1, 2, 3, 4. This will become here 1, 2, 3, 5, right? Correct. 1, 2, 3, 4, 1, 2, 3, 5. Then we have, okay, I'm repeating some 5, 6, 7, 8, 9. So 4 more times I'm repeating. RR4, RR. So 5, 6, 7, 8, and 9. So first let's
We
see
can
how
write
this,
perform until.
yeah, we can, no, we can write. So this is more into how this will be displayed. So just I'm, so we can write. But thing is, this display matters. Basically, if this is not there, like suppose for example, if I just have to write, if I just have to write these two lines, add one and display num1, add one and display num1, add one and, so you can write perform until. Here what I'm trying to show you is this number is displayed as this number, so this part will be repeated. Only thing is what we are writing the raw text inside this, right? 1 2 3 1, 1 2 3 2, 1 2 3 3 will not be displayed. So this here you
Oh,
have to concentrate more on how it is displaying, how it is storing inside this. Okay, yes, we can write perform until also. But thing is, all the displays will be of same text. There will not be any difference. Only this value will be keep on changing, but this won't be changing. Understood, right? So now we are seeing how 1 2 3 0 will be stored, how 1 2 3 1 2 3 4, how all these values are internally getting stored with the sign, right? Okay, let's see. And one more thing, if you are not giving meaning any sign, it will be just stored as it is. So now see here. So 0, it is, I'll show you. One second. Yeah. So if you observe here in zone decimal format, plus 0 will be represented as this. Okay. Plus 1 will be represented as A. Plus 2 will be represented as B. So if you see here, 1 2 3 0, the 0 plus 0 will become this. Plus 1, it will not show 1. but it will show 1, 2, 3 A. A means it is this plus 1. Understand? Plus 2. 1, 2, 3 B. 1, 2, 3 C. So up to 9, you're saying this open curl bracket will become, or it is representing plus 0. Okay. And A to I, A, B, C, D, F, G, H, I is representing positive numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. So plus 1 is A, plus 2 is B, plus 3 is C, plus 4 is D. So this is how internally it will be storing the values. Getting? So if suppose I'm having something called like this. Zero one replace num3 pick s9 of 4 value plus 1 to 3 plus 1 to 3 0 sign leading separate. I'll tell you what does it mean. Wait, but this you understood, right? How it is storing internally, this part.
Yes.
Okay. So we'll see how. So once it is displayed, I'll tell you. We'll see how it will be displayed. So let's see the output now. So So if you want to display the sign also as it is, then you have to mention sign leading separate. So this means sign leading separate. That means you are saying your sign should not be included with the last byte. Your sign should not be combined with the last number. It should have a separate thing. This we use only if you want to display it. If you don't want to display it, this is not required. If you want to display, and then if you're able to understand, then also this is not. If you're able to understand this format, the zone decimal format, then also you don't have to write this. But if you want to display in any particular format, in any particular, report kind of thing, then you have to say sign leading separate. Sign leading separate, what it will do, it will display the sign as well in the leading. Leading means in the front. Okay. If you want to have the sign in the end, you have to write sign trailing separate. Okay. So this just for example, I'm showing this is usually we won't use it. We will be using like this only. Okay. Then next thing is we have seen the positive values, right? Now we will see the negative values. So by seeing this, you already understood how the negative values are stored, right? So -0, closed curl bracket, -1, J till R. So, but let's see that. So first display -1, 2, 3, 0 stored as WS num2 this time. Okay. And I'm saying subtract uh, -1 from WS num2 and display. So when you're subtracting, what will happen? Or is it? It should become minus 1, 2, 3, 1. So display minus 1, 2, 3, 1. Stored, so not minus 1, simply subtract 1. Right? Minus 1, 2, 3, 0, minus 1. It will become 1, 2, 3, 1. Stored as WS num2. So this is 1, 2. How many times we need? Up to 9, right? 3, 4, 5, 6, 7, 8, 9. So till we need 7 times. RR 7, RR 3, 4, 5, 6, 7, 8, and then we have 9. Okay, so we've seen the positive cases and now we'll be seeing the negative cases also. RETP, RETP, and select the option 4 for the previous command and enter slash enter. Let's compile. This is fine. And we're running it. So if you observe here, we will see from here now this part. So minus 0 is closed bracket, closed curl bracket, right? Minus 1 is J, 1, 2, 3 J, 1, 2, 3 K, 1, 2, 3 L, M, N, O, P, Q, R, right? So minus 1, 2, 3, 9 become 1, 2, 3 R. So this is how your signed data will be stored inside your COBOL program or inside your variables. So hope it is clear, right? Now let's move on to decimal values. Decimal or DAC where decimal variable. So first we will start with the normal thing. Let us say I am not having sign also. So suppose I would like to, so let's say I would like to store the value 123.45. This is the value I would like to store. Usually we have all till now we have seen only the normal values, right? 50, 60, 123, 1250, 200, 2000. Only whole numbers we have seen. We haven't seen the decimal values, right? So if I want to see the decimal values or I want to store the decimal, how they are being stored. So how you will be defining them is or how you will be declaring them is simple. Normally, if suppose before decimal you want, let's say you want to store 4 numbers and after decimal you want to store 2 numbers. So simple 9 of 4 dot 9 of 02. As simple as that. And let's say a value I'm giving it as 123.45. This is the value I'm giving. So let's see how it will be stored. There are two ways of defining it. So I'm saying WS num2 And instead of dot, you can give V also. So both basically doing the same thing. If you're giving 9 of 4 dot 9 of 2, or if you're giving 9 of 4 V 9 of 2, both are actually doing the same thing. But there is a difference. There is a small difference. And this is one of the most asked interview question. What is the difference between some 9 of 3 dot 9 of 2 or 9 of 3 V 9 of 2? What is the difference? When both are doing the same thing, when both are saving the decimal values, and when both are storing the decimal values in the same format, then what is the difference? Okay, so let's see what actually will happen and what is the difference. So first thing here, the first point that you have to observe is when you are having the decimal values, you will be defining with before decimal and after decimal. You need to have two 9 clauses. Two 9 clauses. So 9 of 4 dot 9 of 2. That means this is before decimal and this is after decimal. This is before decimal and this is after decimal. This point you are clear, right?
Yes.
Okay. So after that, we are having defining the decimals in two ways. One is point and one is using V. 9 of 4 dot 9 of 2, 9 of 4 V 9 of 2. Let's see the difference. We'll display both the numbers and see what is the difference. So decimal declaration using dot, or I will say using dot. I'm displaying WS num1. Here using V, WS num2. Let us write stop run. Saving decimal var. Now let us compile and run it. Let's go to spool, SJ in front of compile JCL, change the program name, decimal var, and submit. It is having -12. Let's see what is the issue. Value class literal was not it's not compatible with the data category of the. Okay, let's do it this way. Otherwise, here it is. Now it is saying value class is not compatible. Maybe we will move the values. Let's see it later. So it is saying with the decimals, you cannot initialize the value. That's what it is saying. So now it is fine. Let's run it now. Okay, let's see. So I have moved the same value to both the numbers. 1, 2, 3, 4, 5. Same 1, 2, 3, 4, 5 to num2. So I've moved the same value to num1 and num2. Okay. So I'm displaying both the values. Num1 is declared as this and num2 is declared as this. Let's see how it is. So here, this is how you're seeing with the dot. This is what you're seeing with the V. You're seeing any difference
Dot was not there.
Dot is not there, right? So actually, if you're declaring like this or if you're declaring like this, both with dot or v, internally it will be stored as the decimal point only. What is happening is, if you're declaring with dot, externally it will occupy one dot extra, it will be occupying one byte extra, and it will display the dot also. But v is assumed decimal point. It is decimal point won't be there, but it is assumed. That means in COBOL perspective, it is 123.45 only. But when it is displaying, it will not display the dot. Okay. It will assume the decimal point with respect. We will not be occupying any extra space for dot. Dot will be occupying extra space for the dot. That means if they're asking this, how many bytes this will occupy? It will occupy 7 bytes. 4 plus 2, 6 plus dot extra, 7 bytes. But this will occupy only 6 bytes. It will not be occupying extra space for the dot. So in interview, they will give you some numbers and they will ask you how many bytes it will occupy. This will occupy 7, this will occupy 6. But both will be acting as the, if suppose, for example, I'm having a number WS num3, pick 9 of let's say some 04, 9 of 04 dot 9 of 02. Okay, what I'm doing is compute WS num3 equal to, so first we will move some value to that. 1 2 3 some 20, I'm moving to num3. Compute WS num3 equal to WS num3 plus WS num2. So consider if it is 123.45. What will happen if you are adding these two? It should become 5666. So 246.65 it should display, right? If suppose it is not assuming the decimal point, what will happen? Everything will be added to 123 only. This whole 12345. Ask me if you're not understanding. This whole 12345 will be added to the whole number, this 123 only. If it is assuming decimal point only, this 45 part will be added to this 20. Correct or not?
Please repeat it.
Yeah. If suppose what I'm saying here, WS num2 is the assumed decimal point. It is virtually assuming that it will not display any decimal point, but it will be assumed that it is having decimal point. So in COBOL perspective, it is 123.45 only. If you're defining with dot, it will be displayed like this. It will occupy extra space, and here it is 1 2 3 4 5 6 7. But here it will occupy only 6 bytes. So, but in COBOL view, it is 123.45 only. It will not actually display the 45, but it is having internally, it is having because of V declaration. Okay. If suppose what I'm saying, it is 123.45 only. Now you can ask me how you can say there is no dot. How can COBOL consider it as 123.45? So for to show that, to prove that, we are doing one calculation. So I'm having a number 123.20. If suppose it is displaying like this without any decimal point. This one is displaying like this, right? So I am adding WS num3 plus WS num2. So this to this I'm adding. Okay. If suppose COBOL is assuming the decimal point, what will happen? This 123 will be added to this part, and this 45 will be added to this part, decimal part. If suppose COBOL is not assuming any decimal point, this whole 12345 will be added to this 123 only, not to this part, right?
Okay.
Hope you are understanding. Suppose I'm having 123.45. Okay. I want to add 123.20. 20. So how you will write under this, tell me. You will write 123.20, right? Suppose I want to add 12345. How you will write to this? Where you will write? You will simply write 12345 only, not meaning everything you will add to this only, right? This 123 only. This way you will, like this you will add, correct? After this you will not be having anything. You will consider like this. So you're understanding the difference. Add this and this. If COBOL is not assuming any decimal point, it will add like this. If it is assuming decimal point, it will add like this. So I am saying 12345 is getting stored as 123.45. So that means it has to add like this. It should become the result should be, it should have 246.65. This should be your result. Understanding? See, if suppose I'm having 1, 2, 3, 4, 5. So is 1, 2, 3, 4, 5 and 123.45 same?
No.
No, right? There is a difference. So if I am adding, suppose 123.45, I'm adding 10 to this. So it became 133.45, right? So if suppose I'm adding 1, 2, 3, 4, 5 plus 10. So it is 12,355. There is a difference, right? Meaning it will be adding decimal values at the one place and whole numbers at one place. So if suppose consider this way, 123.50 or 10 plus 123.10. So what will happen? 246 will be, so this 123 got added and 11 got added, it became 2. So 246.2, right? So if suppose I am adding, remember this 123.1 I am keeping as it is. Okay. So if suppose 1231.10 and I am adding this time 1231 without any dot, 12310, this is what I'm adding. So what happened? This 12310 got added to 123. This 0.1 is still the same. So this part added to the whole number only, right? That means, so if COBOL is not assuming this as the decimal point, so this whole number will be added to 123 only. If it is assuming this as decimal point only, this 45 will be considered a decimal and it will be added here. I hope it is clear.
Yeah, clear.
Okay. See why WS num3 was not a numeric but was okay. For display purpose, this will not be used. What we can do is this dots won't be working. That is the problem. For all the calculations, only these things we will be working. So what I will do, I'm moving 1230 to this num4. Actually, if you're having this dot is for only display purpose. If you want to see, if you want to say, usually we have to use B only. In the normal things, we have to use v only to tell you, to give you the difference only. I'm explaining this much. This dot will occupy extra space, but this will not be able to participate any arithmetic operations, plus, minus, compute. Nothing will work on this field. Only v things will be working on. V things will be working on it, but other things will not be working on it. But if you want to display, you can display like this. Okay. So 1, 2, 3, 2, 0, I'm moving to num4. So num4 equal to num4 plus num2. And then I'm displaying, I will move this num4 to num3. Okay, display num3 and num4 both. Okay. Now let us run it. Let's see. So when you're adding decimal using this, so this became 246.65 and num4 became 24665. So that means whatever you are adding, so it is considering as decimal point, right? 246. These two you are adding 1, 2, 3, 4, 5, 1, 2, 3, 2, 0. So 5, 6, and 6, 4, 2. 246.65 it is considering. So that means this is what the if you, when you move to num3 to this, but this is without decimal point. But here the thing is, with the dot declaration, it will not be able to participate in any arithmetic operations. That is just for display purpose. If you want to see it properly, suppose you are creating any report, you want to display the amount. So in this format, you will display. But if you want to add something, if you want to multiply something, if you want to subtract something, then you have to use this format only. If you want to do any arithmetic operations on that number, you will have to declare it this way only. This is just for reporting purpose. This is just for display purpose. Okay. Difference is this will be occupying 1 byte extra. This will be occupying, it will not be occupying any extra byte because it will assume the decimal point. It will consider that there is a decimal point, but it will not actually store the extra space for that decimal point. Clear on this?
Yes, any specific name for that V?
No, V letter is assumed decimal point only. We call it as that. The
Okay.
representation is similarly like all the numeric we are making it as 9, right? We are not having any other number. We are not declaring with 1 or 2 or 3 or 4. But I think it is virtual decimal point, but I'm not sure, but I'll see. V is assumed decimal point. Normally either dot or V.
Okay.
Maybe virtual decimal point. I'm not sure. I'll check and tell you. Okay. This is one thing. And if you want to have repl.zdf.zl sign decimal variable. Okay. So to have sign decimal, we don't need all these variables. Just one example is enough. So what I'm saying, sign v. So you will easily understand this. It is very simple. Like how we have seen, right? For 1, 2, 3, 0, it was storing like plus 1, 2, 3, 0 is being stored as plus, meaning 1, 2, 3, open bracket, 1, 2, 3, A, 1, 2, 3, B. Similarly, here also it will be stored like that only. So if I'm move plus 1, 2, 3 dot, let's say, uh, 1, 1, 2, WS num1. display ws num1. Similarly, repeat this and minus.
Sir, you didn't mention stop run.
Right, yes. So we'll write it. Okay. So now let us save it. RETP and 1 enter. So let's compile. Look, let's go to spool. Give SJ in front of compile GCL. Change the program to S and submit. The next thing is run. So same like how we have seen earlier. So the same way it will be stored. Okay. The next thing that we have is comp variables. So I'll give you the introduction of the overview, why we are using comp variable, what is the reason. Okay. 1 second. Okay. Actually, these are comp variables. The full name we call it as uh, computational variables. Okay. So why we use basically what is the purpose of it? What is the reason why we are using it is suppose, for example, the programmers or the the COBOL think that usually every byte or every field is occupying some space, right? Usually, if suppose and we know that COBOL is handling huge data, a huge number of data it is handling. So each field, if you consider in the file, if suppose ICICI Bank employees are there, if it is sending some information, so if it is sending for the information for 10 people, it is fine. 100 people, okay. 1,000 people, 1 lakh. So if it is sending so much of information, they started thinking, is there any way that we can compress the space? Is there any way that we can reduce the storage area? Is there any way we can reduce the space that is being occupied by mainframe? That means if suppose, for example, 9 of 04 is there. So this is consider it is employee ID. So employee ID is 9 of 04. Let's say it is 11112222 like this. So it is occupying here 4 bytes for us for one employee. Suppose I'm having 10 employees. How many bytes it will occupy? 10 into 4, right? So it will occupy 40 bytes. That is also fine. So let's say I'm having 100. Then so consider you have a file. You have a PS file is there. So in PS file, you're getting the information of the employees. So employee details are there, right? So here, consider I'm having only 3 employee details. Let's say 10 are there, 15 are there, 100 are there, 200, 1,000. So like this, in this file, you're having so many employees information. So now employee ID, it will become 400 bytes only for employee. Consider, so I'm here talking about not about name. There are so many other fields, but we are only talking about one single field. One single field is occupying this much space, right? Employee, if it is 10 for 100, this money. If suppose we are having 1 lakh, then how many it will be? It will be occupying 4 lakh bytes just for one employee ID. And there are still other fields. Employee name is their first name, middle name, last name, location, address, salary, designation. So many other fields are there. We are just talking about just one field of the file, right? So this itself is occupying this much space. So they started thinking whether we can reduce the space. Information should not be missing. Information should be as it is. That means if employee ID 111 is there, it should be 1111 only. It should not, get me. It should not become 11 or it should not become 111. It should have the same information, proper information. But the way, is there any way that we can reduce the way or reduce the storage? So then they came up with something called computational process. Computational variables. Those in simple way we call it as comp variables. So suppose if at least 1 byte you are saving for each field, it is 500. That means if I can save at least 1 byte, that means if it is occupying, let's say 3 bytes, it is occupying, earlier it was occupying 4 bytes. After I did something, now it is occupying 3 bytes. How many bytes I have saved? At least 1 byte only I've saved, right? But it is for 1 record. If I consider for 10 records, how many bytes I saved? If I consider for 100 records, if I consider for 1 lakh, right? So if you are saving at least 1 byte for each record also, when it is coming to the whole data, it is so much. Correct or not?
Yes.
Right? So to do this process, to at least we can save the things, we have came up with the process called comp variable declaration. And remember, this is comp variables are purely for numeric values. It will not be applicable on character things. So character, how to save the data or how to save the storage on character variables, that is completely different. That we will be discussing in the 88 level. Okay. This 88 level is for character, how to save. And this comp variables is for numeric. So we will see tomorrow how to use the comp variables, how to declare it. So I think we are done with these two. Also editing characters, I'll say. So we are done with decimal and signed, right? This is done. And I thought of finishing comp also today, but anyway, tomorrow we will finish comp variables. Okay. So we'll see how we will be declaring the comp variables and how we will be able to save the space. Okay. So this is about introduction of comp. And I hope you're clear on the signed and decimal values, right?
Yes.
Okay. So yes, then we'll connect tomorrow. So can we connect at 7:30 tomorrow in the morning, 7:30 to 8:30? Only tomorrow. Is that fine?
Okay.
Hope it is okay for everyone. Is it fine for everyone? So just tomorrow only, 7:30 to 8:30.
Okay, okay, done.
Oh, okay then. Thank you, everyone.